Alright, welcome back to your favorite pre-calculus class. Today we're going to talk about the trigonometric functions, the unit circle. So we're really going to keep going with this unit circle approach here to trigonometry. So we're going to identify a unit circle, describe its relationship, evaluate some trig functions considering the unit circle that we develop, and then use a calculator to evaluate some trig functions as well. Okay, let me make this bigger. Let me go full screen. So trigonometric functions, the unit circle. So now the unit circle is x squared plus y squared equals 1, right? So x squared plus y squared equals 1. If you remember your circle formulas, where hk is your center, r's your radius. So we got this circle here with a radius of 1. Okay, so if we draw that, let's draw this circle, and we have a radius here that's 1, okay? Now if you could imagine for a minute that we take the real number line, okay? Let me see if I can take a real number line here like that, okay? A real number line with that, you see the little dot there, that dot, which is 0 on the real number line, and of course that's the point 1, 0 on your unit circle, okay? So 0 pertains, 0 on the real number line pertains to the point 1, 0, if you will. Okay, we're going to call this t pertaining to some point x, y on that real number line. Okay, so we have these, you can kind of imagine here on this number line, I'm just going to kind of X that a little bit. So each point on the real number line, each value t, if you wrap that thing around it, if you can imagine taking that over and wrapping it around that circle, you have these real number t values that pertain to an xy value. Okay, so like if you were to wrap it around, okay, the whole way around, okay, so the entire circumference of this circle. Okay, if you were to wrap this thing all the way around, like circumference is 2 pi r, right? So if your radius is 1 on this, if you were to go all the way around, you get this real number 2 pi. In other words, that you're intercepting this, right? So S, your arc length, if you were to go all the way around, okay, so you're to do a rotation if you want to think about it that way. If you rotate all the way around, okay, how much have you rotated? S equals R times theta. If you remember, S is our arc length. R is our radius. Remember, our radius is 1 here. Okay. If you rotate all the way around, okay, you've rotated 2 pi amount, right? So your 2 pi, your arc length went all the way around, and that's also your theta. So your theta is 2 pi here. Your S, your arc length that you intercepted throughout that was 2 pi if you were to rotate all the way around. And where do you end up? You end up right back here. Okay, so one full revolution, okay, ends you back up at the point 1, 0. Okay, so what's the real number that pertains to? 2 pi. If you rotate around 2 pi, that's your t value, right? It corresponds to 1, 0. Well, if you go around twice, guess what? 4 pi also corresponds to 1, 0. Okay, so you have this t, these x, y values that are a function of this real number t. If you were to only rotate around, halfway 180 degrees, right? We know that to be pi. Okay, so this pi real number, okay, again, we're wrapping this red line around, wrapping it around. So pi is going to pertain to what point? Well, the point would be negative 1, 0, right? So pi pertains to negative 1, 0, okay? So again, you get all these t values that are, these x, y values, I'm sorry, that are functions of this variable t. So you can use these coordinates to define the 6 trig functions, okay? 6 trig functions. Let's see, how do I get out of this here? Okay, so let's go ahead and define the definition of the trig functions from the unit circle. So definition of the trig functions. Definition of the trig functions. Okay, so we're going to let t be a real number and xy be a point on the unit circle. So we're going to let t be a real number, xy, a point on the unit circle. Okay, which is of course corresponding to t. So we know that the sine, or I'm sorry, we're defining the sine of t to be the y value there, the cosine of t to be the x value, and then the tangent of t. The tangent of t is actually defined as the sine over the cosine. Okay, so it's just y over x in this case. Okay, of course x cannot be 0. Right? And then we have the cosecant of t. The cosecant of t, let me write it right over here. The cosecant is actually the reciprocal of the sine. So it's 1 over the sine, or 1 over y. Okay, of course the y cannot be 0 here. Okay, the secant is defined as 1 over the cosine, or 1 over x. Okay, of course x cannot be 0 here. And then finally you got your cotangent. Okay, your cotangent of t, which is the reciprocal of the tangent. In other words, the other way around, the cosine of t over the sine of t. Okay, so you got your x over y here. Of course, y could not be 0 here, or else this thing is undefined. Okay, so we're going to go ahead and so if you think about that for a minute, you get this unit circle, okay, and you got these t values. Let me see if I can stop here. Let me go to here. Let me copy this. Let me put it on. Paste it right here. Okay, so we got this unit circle. If you can imagine for a minute. Okay, so x squared plus y squared equals 1. So our radius here is 1. We've taken this real number line, right? We've wrapped it around, right? So like pi 6, it's like a little bit more than 0.5, right? A little bit more than 0.5 on our number line. That pertains, this pi 6 pertains to that coordinate there, root 3 over 2 comma 1 half. We talked about pi, right? If we rotate around 3.14 amount, right? Pi, our t value, pertains to negative 1, 0. If we go around all the way, all the way around we wrap it, we go around 2 pi amount, right? Pertains to 1, 0, and so on, Maybe we wrap around 2 pi thirds amount, right? We wrap around 2 pi thirds amount, well, that pertains to there's our t, there's that xy value, right? Okay, so now remember again that the arc length is r times theta, r is 1. So on the unit circle, the arc length is the same as your central angle. So, like if you look at that 2 pi thirds for a minute, here, actually, let me erase this. So if we were to take that in a standard position, we were to rotate around 2 pi thirds, right? Theta being 2 pi thirds, we've rotated around, that arc length has been 2 pi thirds. We're at that 2 pi thirds position on that real number line, okay? And it pertains to that point, negative 1 half comma root 3 over 2. Okay, so you're over negative a half, you're up root 3 over 2 on your Cartesian coordinate system there. Okay, so let's go ahead and do some problems here. This will sink in a little bit better. Okay, so you're looking up above here at these 6 trig functions, right? So we've just defined the sine of t to be y, cosine of t to be x, and so on, right? So you can find the 6 trig functions for, let's say, evaluate 6 trig functions for, let's do t being, let's go with, how about 2 pi thirds? Take that 2 pi thirds, okay? So I look here and I'm like, okay, I've rotated 2 pi thirds. You see it right there? I've rotated 2 pi thirds. Okay, so I'm like right here, right? My arc length, I've rotated around 2 pi thirds. Again, arc length, same as the central angle in this case. You see that? XY value that pertains to, make a note of that. So that 2 pi thirds pertains to the XY value negative 1/2 comma root 3 over 2. Okay, so I say the sine of t, in other words, the sine of 2 pi thirds, by definition, is just my y value, root 3 over 2. The cosine of t, the cosine of 2 pi thirds, is my x value, negative 1/2. The tangent of 2 pi thirds is sine over cosine, in other words, y over x. And of course, we got to finish that off, so go ahead and reduce that. So I got root 3 over negative 1, negative root 3, right? And then we do the reciprocal functions here, so the cosecant. The cosecant, let's find the cosecant of t. Cosecant 2 pi thirds, so that's a 3, which is 1 over the sine, right? 1 over the sine. What was the sine? Root 3 over 2. Root 3 over 2. Of course, we got to simplify that. 2 over root 3. 2 over root 3. So this cosecant of 2 pi thirds. Uh-oh, I didn't leave myself enough room here. This cosecant 2 pi thirds ends up being 2 over root 3. Of course, we're still not done, right? Because we can't have an irrational in the denominator like that. We got to rationalize that. So this, gosh, I'm really making a mess, sorry. Cosecant 2 pi thirds ends up being 2 root 3 over 3. Okay? So we've just done, you see how, so the cosecant is a reciprocal of the sine function. So look at this cosine. Now we're going to do the reciprocal of the cosine, which if you look up here, remember cosine's reciprocal, you see this right here, is the secant. Okay, so we're going to do the secant right now. We're going to do the secant. So secant, the secant of 2 pi thirds, which is 1 over the cosine. In other words, 1 over, and our cosine, if you look up there, is negative 1/2, right? In other words, 1 over the x value. Of course, we got to simplify that. 2 over negative 1, 2 over negative 1. So you get negative 2. Okay. Finally, our tangent. Last one. Tangent. I'm sorry. Cotangent 2 pi thirds, which is 1 over the tangent, or in other words, cosine over sine. So our cosine was negative 1/2. Our sine was root 3 over 2, right? So we got times 2 over root 3 times 2 over root 3, negative 1 over root 3. Rationalize that. You got negative root 3 all over 3. Okay? So there you go. You got your sine, cosine, tangent, and then you got their reciprocals. Cosecant, secant, cotangent. Okay? All from that unit circle. Let's do some more here. I'll leave myself a little more room on this one. Let me move this over here. Okay. Alright, so let's go. Let's again evaluate all the 6 trig functions. Let's do it for t being 4 pi thirds this time. So the sine 4 pi thirds. So you say, well, 4 pi thirds looks like we've rotated 240 degrees, right? So here, I've rotated to there. You know, 4 pi thirds amount, theta being 4 pi thirds amount. Whoops, I'm going to stop here and finish this. It looks like I've hit my end here.